Number 14, we're going to do the dot product, u dot v. This should be fairly easy. So u dot v is -5. -7 is the first vector, dot 3, 5. To find the dot product, you multiply the first two numbers together. Those are your horizontal components, which is -15. You add, and then you multiply the second numbers together, which is your vertical component, -35. And -15 plus -35 is equal to -50. So your answer is D. Next problem, we're starting in on Unit 11 for the last 10 problems, which is our calculus unit. If you are a little shaky on the vector section, don't be too freaked out about that. It was only 4 problems. All right, so looking at limit, the first thing you always want to do is try to solve by direct substitution. Can I put -5 into this and get an answer? And the answer is I sure can. So in place of x, I'm going to put -5 squared, subtract. That's 6 times -5, subtract 6. You square first, so that's going to be a -25. The two negatives here will make a +30, subtract 6. -25 and -6 is -31 plus 30, which is equal to -1. Our answer is A. Number 16, we're going to use direct substitution again to find the limit. So the sine of 5 pi over 6. Well, I know what the sine of 5 pi over 6 is. I'm in the second quadrant, so it's positive. And the sine of just pi over 6 is 1/2. So the limit is equal to 1/2, B. Number 17. I'm finding the limit as x approaches -1 from the right-hand side. So when you see this plus sign, that means from the right-hand side. So I need to pick the piece that's on the right. And the piece that's on the right is that piece right there. So I'll go ahead and just plug in -1 into that bottom piece. Let's try green. So I have 2 times -1 plus 8. That's -2 plus 8, which is equal to 6. The limit is 6. Number 18. Number 18, if I take -2 and I plug it in for x, I'm going to end up with 0 at the bottom of a fraction, which I can't do. So the first thing I'm going to do is simplify this, and I'm going to try to multiply out the fractions in a fraction. So if you look at all the denominators, you'll see that I'm going to multiply the top by 2 times 2 plus x, and I'm going to multiply the bottom by 2 times 2 plus x. This is one of the reasons why we've been working on this strategy all year, is for problems like this. So you can see that in the numerator, nothing's going to cancel, and so that's going to give me, and you're going to keep the limit still. So the limit as x approaches -2, you always keep the limit in your problem until you use direct substitution. So 2x is going to be 2x times 2 plus x. So that's the numerator. The denominator, you're going to see that the 2 plus x will cancel with this 2 plus x, which gives me 1 times 2 is 2. Oh, I think I wanted black pen. Let's try again. 2. And then the 2 is going to cancel with that 2, leaving me -1 times 2 plus x. -1 times 2 plus x. All right, so I'm going to see if I can scroll down a little bit. And we're going to keep working on this same problem. I'm going to go ahead and simplify. So this equals the limit as x approaches -2. I'll leave the 2x. So I have 2x times 2 plus x. And in the denominator, I'm going to go ahead and distribute that -1. So this is 2 subtract 2 subtract x. So this is awesome because the 2 minus 2 is going to cancel. This gives us a negative x in the bottom. The x is going to cancel with that x, but we still have a negative. So we'll go ahead and put that negative up in the top. So this is going to equal the limit as x approaches negative 2. In the top, we're going to have negative 2 times 2 plus x. And see this negative, I brought it up top here. All right. Now, we can go ahead and use direct substitution at this point. So if I take, in place of x, I plug in negative 2. So this will be negative 2 times 2 plus negative 2. And that's going to give me 0, which is okay. I can get 0 for an answer. So if I scroll back up to the original problem, the limit as x approaches negative 2 of this function is going to equal 0, b. So in this problem, you can't directly substitute 16 because you're going to get the square root of 4 subtract 4, which is 0 in the bottom of a fraction. So you can see I'm multiplying the top and bottom by the conjugate, which is the square root of x plus 4 over the square root of x plus 4. The limit as x approaches 16, now I'm going to see what I end up with in the numerator. So in the numerator, I have x subtract 16 times the square root of x plus 4. We're going to leave that for now, and then let's go ahead and multiply out the denominator. So the denominator is the square root of x times the square root of x is simply x. Outside insides are going to cancel, and then negative 4 times 4 is subtract 16. Now the reason why I didn't multiply out the numerator is because I was hoping for something in the denominator to cancel with something in the numerator. Now I can just go ahead and use direct substitution. So once you use direct substitution, you can drop the limit, and I'm not really dropping the limit, I'm just taking the limit, which is the square root of 16 plus 4. This equals 8. So let me scroll back up. Oh, it's right here. So answer is 8D. Looking at number 20. So number 20, if I use direct substitution, negative 4, and plug it in, then I'm going to get 0 at the bottom of a fraction. So that is not going to work. The next thing I want to do is, because this is a rational function, I want to just go ahead and graph it so that I can see what's happening with the limit as x approaches negative 4. So I just used Desmos to graph it, and here's the graph of this function, and you can see that there is a vertical asymptote at negative 4, and so we are going to need to determine if I'm coming into this from the left-hand side, then I'm dropping to negative infinity, and if I'm coming into negative 4 from the right-hand side, I'm going up to infinity. And so that means that the limit is not going to exist because I can't approach from two different places. Looking at number 21, this is the one that I wanted you to have memorized, the limit as x approaches 0 of sine x over x. This is what the graph looks like. So as we're coming into this graph from the left side towards 0, f of x is 1, and as we're coming in from the right side towards 0, f of x is 1, so therefore the limit is 1. All right, looking at number 22, if I were to directly substitute 3 into this denominator, I am going to get 0 on the bottom of a fraction. So I'm going to try to solve this first by actually factoring. So this is going to be, oh, I need my pen, the limit as x approaches 3 from the left-hand side. And I'm going to leave the negative out in front. There is a negative out in front. I have x subtract 3 in the numerator. In the denominator, when I factor, I'm going to get x subtract 3 and x plus 1. Whoops, I didn't need that extra parenthesis. X subtract 3 and x plus 1. So you can see that this is going to cancel, And now I can use direct substitution by substituting in 3 into here. Now, this minus sign just means we're coming in from the left. So we're not going to have to really worry about that. If you were looking at the graph of it, then you would look from the left side coming in to the number 3. So the limit as x approaches 3, oops, that's not negative 3. The limit as x approaches 3 from the left side of 1 over x plus 1. So let's go ahead and in place of x, I need you to substitute in, trying to get these pens to work. X, you're going to substitute in a positive 3. So what does the limit equal? The limit equals 1 over 3 plus 1, which equals a 4th. However, this is negative because there was a negative out here, which I should have carried through. So the answer is B. Good thing it's multiple choice, so I might have missed it. Number 23 is the limit as x approaches infinity. When we're going to infinity and it's a rational function, then I can just, if I find the horizontal asymptote, then I'll also have the limit. So this is top heavy, which means that the limit does not exist. Now, because this is a rational function, I don't know if it's going to be A or C, because A and C would both be does not exist. So I'm going to have to go to Desmos and graph this so I can go to the right of the graph as I approach positive infinity to see if the graph is going up or the graph is going down on the right-hand side. So I'm going to go to Desmos and graph it. So this is what this graph looks like. So if I move over to the far right-hand side of that graph, so I'm coming way over here to the right, you can see that this graph is going down to negative infinity. So this one's going to be A, negative infinity. Okay, the last problem of the day, hurrah, is 24. 24, if you didn't want to do it by Riemann sum, you could probably throw it into your calculator as an integral. So this would be the integral is going to go from -1 to a half, and then you would put in negative x plus 5 times dx. And that's going to give you a pretty good approximation for the area under the curve. Now, I'm going to go ahead and do it the long way. I'll stop it and draw out the rectangles, and then we'll go from there. So the first thing I did is I graphed this function on my graphing calculator, and then I graphed it here on graph paper. I used a table to help me. It's okay, it's not the best. So now I'm looking for the area between -1 and +1/2. So you can see I've blocked off this area. Now it's asked me to use 3 rectangles. So to use 3 rectangles, the first thing I have to do is just find the distance between these 2 points. So we know that from -1 to 0 is 1, and then from 0 to a half is a half. So I'm looking at 1.5 or 1.5 divided by 3. This means each of my intervals is going to be 0.5 or a half. So from -1 to a half, I will draw a rectangle from to -1/2. From -1/2 to 0, I'll draw a rectangle. And then from 0 to a half, I'll draw a rectangle. And I want those to be on the left side of this function. So you can see that this hits on the left, and then let me draw those. So you can see I drew my 3 rectangles, and they're okay, they're not perfect. But I'm trying to find the area inside of these rectangles. So here's my first rectangle. So to find the area, the width of these rectangles are 0.5, and then I'm going to take f of -1, which is that point, f of -1/2, which is that point, and then f of 0, which is that point. So to take f of -1, you take -1 and you plug it in for x. So f of -1 is equal to the opposite of -1 squared over 2 subtract -1 plus 5. So this is the opposite of 1 over 2 plus 1 plus 5. So that's going to give me 6 subtract a half, which is 5.5. So this is going to be 5.5, or you could write it as 11 halves, plus, then you're going to do the same thing for f of -1/2, and then you're going to do the same thing for f of 0. So I did f of -1, f of -1/2, and f of 0. And I'm going to add those together and multiply by 0.5, and that's going to give me the area of these 3 rectangles. So there's my second rectangle, and here's my third rectangle. And you can see that the area is a little over the actual area. And so this is going to give me 7.938. And I'm really hoping that that answer choice is there. I'm going to have to go back to my other screen. There it is, B. Yay! So excited that my answer's there. So there's 24. So now we just have one last problem and we're done with this review. And then if you have questions on it, please email me. We can set up a conference and do some problems together if you need me to. 25 says, find the instantaneous rate of change of the function at the given value, which is 1. I'm going to do this problem the long way, but if you remember the calculus trick from the video, then I encourage you to try this the quick way. So the long way is to take the definition of limit, which is the limit as h approaches 0 of f of x plus h minus f of x over h. And so the first thing I'm going to do is this is f of x, so I'm going to go ahead and find the limit as h approaches 0. Again, I can't use direct substitution because that will give me 0 on the bottom. And the first time everywhere I see an x, I'm going to put in an x plus h. So this is the opposite of x plus h squared plus x plus h, subtract 2. Then I'm going to subtract f of x, and f of x is the opposite of x squared plus x subtract 2, and this whole thing is over h. Now I'm going to simplify the numerator. Over here, I did x plus h times x plus h. You have to do first, outer, inner, last, and then there's a negative out in front, and this is what I ended up getting. So now I'm going to simplify what I have so far. So I have the limit as h approaches 0. This part is over here, so that multiplied out is negative x squared subtract 2xh subtract h squared. I still have x plus h subtract 2, and then a negative times a negative is a positive x squared. A negative times a positive is a negative x, and a negative times a negative is a positive 2. One big mistake I see is students don't take that negative and distribute it through, making sure that when you do subtract f of x, you have to subtract the whole thing by using those parentheses. Okay, I'm getting pretty good at this now that we're about done. So this whole thing is over h. We're going to go and cancel like crazy. So x squared, negative x squared. 2, negative 2. Opposite of x, x. And does that give me everything? Yeah. So let's see what we have left. So this is going to be the limit as h approaches 0. And I've got negative 2xh plus h subtract h squared. So that's what I have going on. So negative 2xh subtract h squared plus h all over h. We can go ahead and factor out an h in the numerator. So that's negative 2x subtract h. And then that h factored out is going to give us a 1 all over h. And I forgot the limit. This is the limit as h approaches 0. So notice our h's are going to cancel. And now I can use direct substitution. So I'm going to take 0 and plug it in for h. And the limit is actually equal to negative 2x plus 1. Now, I am not done yet because I want to know the rate of change when x is equal to 1. So all I have to do is take this derivative and plug in 1 for x. So negative 2, I'm going to plug in a 1 for x. So times 1 plus 1. Oh, darn it. I'm trying to be fancy and it didn't work. So negative 2 times 1. I want to go back to black for the grand finale. Plus 1. Negative 2 plus 1 is negative 1. And so the rate of change is C, negative 1. All right, thank you very much. It's been a pleasure. If you have questions, you're welcome to email me. I can set up a Google Hangout conference and we can work on some of these together. When you feel like you're ready, just go to Google Classroom, take the test on this unit, and go to the notes section and fill out your questionnaire on the notes and make sure all your homework's submitted and you're completely done. Thank you. See you later.